Hi, my name is Vicky, and I'm a math tutor at Lehigh Carbon Community College. Today I'm going to talk to you about dosage calculations. For many nursing students, dosage calculation problems can seem confusing or intimidating or even overwhelming. But I'm going to give you a strategy today that you can use for every single dosage calculation problem. Almost every dosage calculation problem requires some kind of conversion, moving from one unit to another unit of measurement. That's the basis of every dosage calculation problem. And I'm going to give you a method today I call it the multiplication method, but you may have heard of it as dimensional analysis. And as I said, you can use dimensional analysis for every single dosage calculation problem that you encounter. When you start a dosage calculation problem, you're going to ask yourself two questions. The first question you're going to ask yourself is, what is the problem looking for? So this is your answer, right? What is the problem looking for? What's it asking you to find? Is it asking you to find how many tablets a patient needs, how many milliliters need to be delivered, how long a patient needs to be on an IV for? This is very important. This is what the problem is looking for. And it's important to keep this in mind as you're working through your dosage calculation problem. So I suggest you circle, you can highlight or underline, whatever you want to do, but indicate this in the problem. So circle or underline, you can even highlight if you want. What is the problem looking for? What is the answer that you're trying to find? Now, the second question you're going to ask yourself is, what information do we need to get us there? So what information do we need in the problem to get us to our answer? So, as I mentioned earlier, every dosage calculation problem requires some kind of conversion. You're going from one set of units to another set of units. That's the core of every dosage calculation problem. So you can also highlight, circle, underline this information in the problem as well. This information that we might need to get us there. And this would be your conversion factor. And I will talk more about conversion factors in a little bit. So this is the information that you're going to need to get you there, will be a conversion factor. So down here, I have a table. These are the 4 things that you're going to look for in your dosage calculation problem. First, here is the desired dose. This is the dose ordered by the doctor or the physician. So in your problem, if it says order 500 milligrams of ibuprofen, something like that, this is your order. This is the amount of medicine that the patient needs to receive. This is your order. This is always what you're going to start with. Next, we have the dose on hand. This is the amount of drug contained in each unit. The dose on hand and the dosage unit go together, and I'll explain that a little bit later as well. So the dosage unit is how the drug will be administered, tablets, milliliters, etc. So the dosage unit would be how are we transmitting, how are we getting the drug into the patient? Is it going to be via tablets? Is it going to be via IV or a liquid, which would be a milliliter amount? That sort of thing. So it's also known as the vehicle because it transports the drug into the patient. You may have heard it referred to as the vehicle. So the dose on hand is the amount of the drug that is contained within each unit. This is usually a milligrams or milliliter situation. Finally, the amount to administer on the bottom is what you will give to the patient. This is the answer to your problem. This is usually what you are looking for. from your first question. Your first question that you asked yourself is, what is the problem looking for? The amount to administer is usually going to be the answer to that question. How much of the drug do you need to give to the patient? How much of the dosage units do you need to give to the patient so that they receive the desired dose? So you need these three things here. You need the desired dose, the dose on hand, the dosage unit. All of those things are going to influence the amount of the drug that you are going to administer to the patient. This is where conversion factors come in. So what is a conversion factor? In my words, it's a tool that you can use from going from one unit to another. So usually your desired dose might be in different units than the amount to administer. The amount to administer might be, you might need to administer 3 tablets to a patient. Well, this isn't going to be in the same units as your desired dose. Your desired dose might be in milligrams or grams, but your amount to administer might be in tablets or capsules or something like that. So, and as I said earlier, every dosage calculation problem, the root of them is going from one unit to another unit. And how do we do that? That's our second question. What information do we need to get us from one unit to another unit? How can we get us there? And that's where your conversion factor comes in. Your conversion factor is that tool from getting you from one unit to another unit, from getting you from the desired dose to the amount to administer. A conversion factor is a proportion, or a fraction, or a proportion with 2 distinct units. And the 2 distinct units is important. So as an example, I have a couple examples here on the left. The first one, a fraction, 1,000 milliliters over 1 liter. And this tells you that there are 1,000 milliliters per every 1 liter. For every 1 liter, there is 1,000 milliliters inside of that liter. It gives you the relationship between milliliters and liters. It gives you a relationship, a roadmap between 2 different kinds of units, milliliters and liters. Same thing with the second example, 500 milligrams in 1 tablet. This gives you the relationship between how many milligrams of a drug are contained within 1 tablet. Now, these are 2 separate kinds of conversion factors. The first one, 1,000 milliliters over 1 liter, is going to be consistent throughout every problem that you have. There will always be 1,000 milliliters in 1 liter. But the second one, depending on the question, depending on the drug, depending on the patient, there may be different amounts of milligrams within tablets. So there are 2 different kinds of conversion factors there. But they both serve the same function. They give the relationship between those 2 units. In every 1 tablet, there is 500 milligrams. It's giving you the relationship between tablets and milligrams. And this is very important because this is how you're going to get from 1 unit to another, using that relationship provided in your conversion factor. As I said, this is the information that we need to get us to the answer. So reviewing the 2 questions that we're going to ask ourselves when we're starting a dosage calculation problem. What is the problem looking for? That's the amount to administer, right? We're going to circle or underline this information in the question. Second, what do we need to get us there? How can we go from 1 unit to another? We're going to look for conversion factors. We're going to look for the relationships between units that is given to us in the problem. So that's our general strategy. That's our general strategy for every single dosage calculation problem. So how do we do this in practice? What's our strategy? What's our method for actually solving this? How do we How do we actually use conversion factors to get from one unit to another? We're going to use dimensional analysis, or the multiplication method. I've reproduced the table here for your reference. So, multiplication method or dimensional analysis. Remember, there are 4 things that we're looking at in our problem. The desired dose, which was what the doctor ordered, how much of the drug the patient needs to receive. Dose on hand is the amount of drug contained within each unit. It's the amount of milligrams in a tablet, the amount of milligrams in a milliliter, that sort of thing. And the dosage unit would be how we get that drug into the patient. Is it by mouth, by liquid? Is it IV liquid? Is it tablet, capsule? That sort of thing. That's your vehicle. That's your dosage unit. And then the amount to administer is what we're giving to that patient. The amount of vehicles that we're giving to that patient so that they get the desired dose. This is your strategy every time you are applying it to a dosage calculation problem. This is how you're going to set it up. I have a formula down here. It says D times Q over H equals A. D being your desired dose, that's the order, and you're multiplying that by the dosage unit, or the vehicle, over the dose on hand, how much is contained within that vehicle, and that's going to give you the amount to administer. That's going to give you your A. And A is actually the answer to the first question that you asked yourself. What is the problem looking for? That we circled or underlined. What is the problem looking for? We're going to multiply the desired dose by Q over H, and that's going to get us equal to A. So where does the conversion factor fall into place here? This guy right here is our conversion factor. It's a fraction, right? It's a fraction, and it's going to be in 2 different units. The Q and the H, the dosage unit and the dose on hand, are going to be in 2 different units. That's going to give us the relationship that we need to get from the desired dose to the amount to administer. Let's do some examples. Here we have a tablet calculation problem. The example asks us to find the amount to administer. We have Famvir, 1,000 milligrams. That's our order. The doctor said the patient needs to take. And on hand, we have this label here. It's Famvir tablets, and it says 500 milligrams per tablet. Okay, so what's our first question that we ask ourselves? What's the problem looking for? What's the answer that we're trying to get to? So the problem asks us to find the amount to administer. What is the amount to administer? What are we looking for? Well, the patient needs milligrams of this drug, and what we have on hand are tablets. So the patient can only get this drug via tablets. So we're going to have to administer tablets to the patient. So what the question is asking us is how many tablets are we going to administer to the patient? So our answer is going to be in tablets. That's what we're looking for. So let's start with our formula. Desired dose multiplied by the vehicle over the dose on hand is going to give us how many tablets that we need. And remembering that this guy here is our conversion factor. So let's plug in what we know to this formula here. Our desired dose is what the doctor ordered, 1,000 milligrams. Doctor ordered 1,000 milligrams for this patient. And we're going to multiply that by the conversion factor. What's the relationship How can I get from milligrams to tablets? What's the relationship between milligrams and tablets that I have? Well, Famvir here on the label tells us that there's 500 milligrams per every tablet. So the vehicle, how is the drug going to get into the patient? Tablets. That goes on top. 1 tablet over 500 milligrams, dose on hand. For every tablet, 500 milligrams. Now, we make sure we cancel out our units when we do our multiplication. The milligrams here, from the dosage ordered, the desired dose, are going to cancel out with the milligrams for the dose on hand. And we have 1,000 times 1 on the top here, tablets, over 500. And if you do this math here, that's 1,000 on the top. 1,000 divided by 500 is going to give you 2. So this patient needs to take 2 tablets of Famvir here in order to get 1,000 milligrams of the drug. So you can see that the conversion factor here gave us the relationship between milligrams and tablets, because we needed to go from milligrams to tablets. We needed to convert milligrams to tablets. And the conversion factor there gave us the relationship for how we could get there, how we could get from one place to another. Let's try another example. This is a flow rate problem. We're going to be looking at adjusting a flow rate. So the example asks us to calculate the adjustment in drops per minute. The original order was 1,500 milliliters normal saline over 12 hours. So the patient needs to receive a total of 1,500 milliliters over 12 hours of time of infusing. The IV was infused at an ordered rate of 42 drops per minute using 20 drops per milliliter macro drip tubing. After 3 hours, 1,200 milliliters remains in the bag. Okay, what's our first question? What's the problem looking for? What are we trying to find? So the example asks us to calculate the adjustment in drops per minute. The adjustment in drops per minute. So we have to adjust the flow rate. So our answer needs to be in drops per minute. That's what we're looking for. What information do we need to get us there? That's our second question. So what are we starting with? What's our desired dose? You might think that it would be the original order here, 1,500 milliliters over 12 hours. However, the IV has already been infusing for 3 hours, and 1,200 milliliters remains in the bag. This means that for the remaining time that we have, we still need to infuse 1,200 milliliters. So 3 hours have passed since we started, which means we have 9 hours left to infuse 1,200 milliliters. So that's our new desired dose. That's our order. So our desired dose is 1,200 milliliters inside of 9 hours. Now I need to multiply by a conversion factor to get me to the amount to administer. I need to get myself to drops per minute. What's my relationship? What are the relationships that I can find? So I have milliliters on the top here, 1,200 milliliters on the top, and I'll need to change that into drops. And then I have hours on the bottom, and I'll need to change that into minutes. So let's look at what the problem gives us. The IV was infused at an ordered rate of 42 drops per minute using 20 drops per milliliter macro drip tubing. So this right here, this is the original flow rate. We don't need to care about the original flow rate for this problem right now, because all we need to do is to figure out what the new flow rate should be from our new desired dose. We need to get 1,200 milliliters into the patient inside of 9 hours. Doesn't matter what the original flow rate is. Many dosage calculation problems will often provide unnecessary or extraneous information in the problem to try and trick you up. But as long as you know what you're looking for, what the problem's asking you, and what information do we need to get us there, as long as you know those things, you can better navigate your way through dosage calculation problems and through that unnecessary information. So, what other information do we have? I need to go from milliliters to drops. This macro drip tubing, 20 drops per milliliter, this gives me a relationship that I can use. So let's multiply by that conversion factor, that relationship between drops per milliliter. Now, sometimes you may need to multiply by more than one conversion factor in order to get yourself to the amount to administer. This would be the case in this problem here. If I were to do this multiplication, focusing on just the units, the milliliters would cancel out with each other, right? And we'd be left with drops per hour on the bottom, but we don't need drops per hour, we need drops per minute. So it's important why we circled that in the beginning, so that we remember we need drops per minute. So we'll need to multiply by another conversion factor. And this one's not given in the problem, but I need to go from hours to minutes. So what's the relationship between hours and minutes? Well, there's 60 minutes in every hour. So I'll multiply this formula here also by 1 hour over 60 minutes. And I made sure to keep hours on the top so that the units would cancel out with each other. So when we do this multiplication, milliliters are going to cancel, hours are going to cancel, and we have 1,200 times 20 drops over 9 times 60 minutes. And if you do this, this multiplication and division, I promise I did not do it in my head, you're going to get to 44.44 drops per minute. And depending on what your professor's rules are for rounding, you could round this down to 44 drops per minute. So in this problem, we needed to multiply by 2 conversion factors to get us to the amount to administer, which would be the flow rate in this case. Let's try another one. This problem focuses on a total time to infuse. So it asks us to find the total time to infuse, and it gives us the order of 1,000 milliliters, normal saline, to infuse at a rate of 75 milliliters per hour. Okay, so we're looking for the total amount of time that we need to take so that 1,000 milliliters can be infused into the patient at the given rate that it gives us, which is 75 milliliters per hour. Question 1, what's the problem asking us? What are we looking for? Well, we're looking for a total time. So it doesn't exactly give us hours or minutes, so we're not entirely sure if we need to write this in hours or minutes. But we know we need a time. So depending on what our answer looks like, we can write it as hours or write it in terms of minutes. But we know we're going to need a time. All right. What information do we need to get us from the desired dose to the amount to administer? What's the desired dose? 1,000 milliliters. I'll do that in black. 1,000 milliliters is our desired dose. The patient needs to receive 1,000 milliliters. And we need to find a relationship between milliliters and hours then. Milliliters and some unit of time. That's going to be our conversion factor. This guy right here gives us a relationship between milliliters and hours. So let's set up our problem. Desired dose, first thing, multiply by our conversion factor. Now be careful with this one, because if we just multiply by this, we just take that conversion factor and just multiply by that, the units here, the milliliters, are not going to cancel out with each other. And that's important. We need those units to cancel so that we're just going to be left with hours. So rather than write it this way, we can flip it. And this is perfectly mathematically legal. You flip your conversion factor. Because all you need is the relationship between milliliters and hours to get you from milliliters to hours. That's all you need. So you can multiply by the flipped fraction, which will cancel out our units. And that will give us 1,000 times 1 hour over 75. And if you do this multiplication and division, you will end up with 13.33 hours. This would be your final answer. You found the total amount of time it would take to infuse 1,000 milliliters at a rate of 75 milliliters per hour. However, it might be better if, rather than leaving this in decimal form, we would write this as hours and some amount of minutes. Someone just looking at 13.33 hours might not be able to say, oh, this is exactly how much time in minutes that the patient needs to be on the IV for. So we need to convert this guy into hours and minutes. Let's talk about how to do that. So 13.33 hours. So there's 13 full hours that it takes. It's going to take 13 full hours, and then also 0.33 of an hour. And so we just need to figure out, how can we write 0.33 as a minute, as a minutes unit? 13 full hours, and then 0.33 of an hour. So we have to convert then 0.33 hours into minutes. So we'll multiply by that conversion factor, which would be 60 minutes over 1 hour. So that the hours cancel out, and I'll just be left with minutes. And this will leave us with 20 minutes. So rather than writing 13.33 hours, you would write 13 hours, 20 minutes, which is a lot more straightforward. So here for this problem, we did one conversion factor to get us to our answer. But to make our answer look a little better, to have it be more easily readable, we did another multiplication, another dimensional analysis to leave us with our answer. For our final problem, let's do an example based on weight. So the question asks us to calculate the amount to administer to a 3-year-old who weighs 34 pounds. The order is hyoscyamine sulfate, 5 micrograms per kilogram. On hand, hyoscyamine sulfate, 0.5 milligrams per milliliter. So, what are we looking for? We need to calculate the amount to administer. And let's think about what units that will be in. It might not be readily apparent in the problem. So, if we look at the drug on hand, the hyoscyamine sulfate is 0.5 milligrams per milliliter. So what's the vehicle? What's the dosage unit? How are we getting the drug into the patient? Well, also in the order, it tells us it's going to be subcut for 1 hour. But also this milliliters here, so this is going to be a liquid. So it's going to be intravenously. I think that's what subcut means. So for every milliliter, there's going to be 0.5 milligrams of the drug. So the amount to administer, it's going to have to be in milliliters. We're going to need to administer a certain amount of milliliters so that the patient gets the drug that they need. So we're looking for milliliters. Our answer is going to be in milliliters. Now, what information do we need to get us there? Well, first we need to find out what the desired dose is. So we can look for the proper information to get us from the desired dose to the milliliters. So what's our desired dose? Let's look at the order. It says 5 micrograms per kilogram. So what is that? Let's talk about what that means. So 5 micrograms per kilogram. What this tells you is for every kilogram that the child weighs, he or she needs to receive 5 micrograms of the drug. It's a wonky looking 5. So for every kilogram that the child weighs, they need to receive 5 micrograms of the drug. So if the child would weigh 1 kilogram, they would receive 5 micrograms of the drug. If they weighed 2 kilograms, they would need to receive 10 micrograms of the drug. So this here is your own, it's a conversion factor, right? Because it's giving you a relationship between 2 different units, micrograms and kilograms. So we need to find out how much of the drug the child needs to receive based on its weight. His or her weight. So the child weighs 34 pounds, and the weight is going to determine how much medicine the child is going to receive based on our conversion factor here. So 34 pounds is what we're starting with. We need to eventually get this to how much of the drug the patient needs to receive, which will be in, first we'll do it in micrograms here. Well, I can't just multiply by this conversion factor here that I'd like to, because we have kilograms and we need it, or we have pounds here, we're starting with pounds, and we need it to be in kilograms. So we need to multiply by a conversion factor to get us to pounds to kilograms. This might be a conversion you're familiar with. 2.2 pounds in every kilogram. So we'll multiply by that conversion factor. The pounds will cancel. And then we will multiply by this conversion factor here, the one that it gives us in the order. 5 micrograms for every kilogram. The pounds cancel. The kilograms cancel. And we'll be left with 34 times 1 times 5 micrograms on the top over 2.2 times 1 on the bottom. Okay, and this here will give us, if we do this multiplication, this will give us 77.27 micrograms. So this is your desired dose. The child needs to receive 77.27 micrograms of the drug. Now, how do we get the desired dose to amount to administer? How do we get from micrograms to milliliters? What's a relationship between micrograms and milliliters? We're going to use the dose on hand in the vehicle. Right here, we have 0.5 milligrams per milliliter. So we're going to use that because that gives us a relationship between weight, milligrams, and a milliliter. But we just have to be careful that we're multiplying by a conversion factor to get us from micrograms to milligrams first. So in a milligram, there are 1,000 micrograms. So we multiply by this to make sure that the units of micrograms will cancel out and we'll be left with milligrams. Then we can multiply by this right here. Milliliters will go on top so that the micrograms will cancel out. The milligrams. So we'll cancel. I have 77.27 times 1 milliliter on the top, 1,000 times 0.5 on the bottom, and this will leave you with 0.15 milliliters. So with this problem here, we actually needed to calculate the dose on hand for this problem here, because the order given by the doctor was a conversion factor. So we needed to figure out, based on the child's weight of 34 pounds, we needed to figure out how much of the drug the child needed to receive. We needed to figure out the desired dose. Then we used the dose on hand and the dosage unit to get us from the desired dose to the amount to administer. That's it for today. Thank you very much for watching this video. I hope it was helpful for you. Have a great rest of your day.